Okay, for people who are here on the live stream, this is another episode of an internal design review of an upcoming version of Wolfram Language. And the topic, this is actually our third meeting that we've live streamed today, and our last for today. And this particular one is about design of tree structures, representing trees for any purpose for which you might represent trees, symbolic trees, I guess, in Wolfram Language. Okay, let's get started here. So I think we thought we had a fairly final design last time. Is that true?
Yes, we finally decided on the syntax and the number of arguments. There are still a few questions that we could discuss today. I have recalled the syntax for each of the symbols that we will have and some basic examples. If you want to go through them, or otherwise we can directly go to the question.
Let's go ahead. Hold on 1 second here.
While we're paused, Xavier, can you bring the microphone a bit closer to you or maybe boost the gain? You're coming very faint, at least to me.
Me too.
Is it better now?
Yes, that is better. Okay, where should we start looking at this? All right, so the basic idea is tree elements of vertex data, subtrees, and options, right?
Yes.
So we didn't do the graphic design of this yet.
No, not yet. I've discussed this week with Chris, so we are starting to look at that.
Chris who? What? Oh, Chris Parodi.
Yes.
Yeah. Okay. Okay. So what are you showing me here?
So yeah, here the idea is to show that in the vertex data we have some reserved keys. So name is the one we discussed last time. So it will say what we are going to display in the node. And we used to have an option called vertex label. And we were not happy with that, so we decided to change it to a key in the data that will affect the display. So if you take the example with name goes to 1 + 1 and label goes to A, we see that it's A, it's displayed.
Okay. Now this property thing, that's an arbitrary property, right? You can have an arbitrary list of, I kind of hate having these kind of reserved names in this association. I mean, did we discuss this endlessly, having a thing called properties, which then has its own, is it a sub-association?
No, we did not discuss that. So here, yes, we can give any other keys and any other value. Yeah.
I understand, but I don't like having, I really don't like mixing, name and label, which had happened to be our particular names, with the other ones.
Yes, so we could use a property goes to and then an association.
We have discussed several times the separation between user properties, built-in properties, and decoration properties. And we have had several alternatives. It's a difficult decision.
Okay, but wait a second. Why is... Okay, so vertex data is of this node, right?
Yes.
Yeah.
Features of this node. Then subtrees, then options. So why, as name and label, why are they not in options?
Well, vertex label used to be an option, but we wanted to change that to label in the vertex data. And name, from the beginning, it was always not an option. So yes, I would say that everything that is going to affect the display should go as an option. So even label should go back to an option. But then we will have to see what will be the better name, the best name for that. Last time we were dealing with vertex label, so singular, and we don't have this this symbol in the language, so we could always introduce this new symbol.
Yeah, if we want to call it, I mean, this is... Okay.
So,
well, go ahead.
Yeah, so I'm Either I'm forgetting, or perhaps I missed a previous meeting, but what's the division between vertex data and options?
Well, now, yes, that's one of the issue now, yes. Before used to be that everything which affect the display is in the option. And in the data, we only had one reserved key, which was the name.
Right, and then anything else was arbitrary user data that
Yes.
they wanted to associate with that node.
Yes, exactly. And there was another discussion whether we should separate the reserved key from the custom key. So
what about the possibility? Yeah, I mean, so, you know, look, does every tree element have a name?
No. You don't need to provide one. You can just type an empty association or association of something which does not contain the key name, and you won't have the name and you won't have the associated display. So you don't need to give the name always.
But the second element is the subtree, right?
The second element is the subtree, that's correct.
And so one thing we definitely want is that at the leaves of the tree, one can do something like this, right?
Yes, 3-element leaf 1, yes.
But you can't do that right now because you have to have this crazy association with full of gunk.
No, so here we have the shortcut. I think it's a bit above, I don't remember, but you can just directly use a vertex name actually. So you don't need to, yes, this is the first one. So this actually parsed to an association with the key name, but this is a short version as input.
So if the name of the association was itself an association, you would have to use the fully qualified form.
Yes.
Well, this isn't so crazy, Itai. I mean, look at this case. This is not so crazy because this will be what people do most of the time. And most of the time, people will, if they want to stuff extra properties into this node, it seems okay, actually. What do other people think?
I agree that if it's, not association is just the name. I mean, does it evaluate then to an association, or is it just treated as a?
What is the canonical form?
It does evaluate to an association, yes. So this is the first input form we can see.
Yeah. That's going to be, well, I guess we have mostly tree accessor functions rather than people going in raw with the expression. Right, so that's not such a big deal.
Perhaps the problem is in name. We could call it data. It will be clearer.
Shouldn't be data the whole association?
Yeah.
I wonder if it should be value. Right, because so maybe I'm just thinking of binary search trees, but on some level, I think the main thing you stick in there is the value, and then and then you might associate extra stuff with that value.
Okay, what about the possibility, whatever it is, its name is, and then having an optional association of all kinds of other properties here? What about having something like this?
Okay, wait. So you will always have a name then?
You would always have a name. I mean, you could have none if you want to as the name.
Mm-hmm.
But that will be a rare case, won't it?
Yes, I think as soon as we are able to typeset as if there was no name, it's okay.
Well, wait. In this, if you have a sub-element, if you have an intermediate node in a tree, there are two different things. Either the intermediate node has a name in it, or it doesn't. If it doesn't have a name in it, it doesn't have a big blob of yellow there.
Mm-hmm.
Right?
Yeah, that's correct, yes.
So there's a certain argument that that we could have special values, none and automatic, that automatic corresponds to an empty yellow marker, and that none means absolutely nothing there. And then otherwise, it's whatever the name should be. And that if you want to put in properties, you say arrow a property association. Thoughts from people about this? Anybody got comments on that?
It's certainly in keeping with things like what's a good example? But we have precedents for things like this, even though I can't think of one. But I guess like a nearest, right, where you look by this but return that, right? So I think this is
okay.
pretty sensible.
We were planning to have tree-element taking like keys to extract things. So then we might have an asymmetry between extracting the main value from the secondary values. So having a single association which says data or value goes to something would keep more.
Do we really want to call it value? I mean, I don't think it is value.
Content, even name. I don't know. Data.
I don't think it's data. It might be name, but.
Right, but well, I personally think I'm not sure I understand the difference between name and label.
So here, name was really to echo what is done for graph. So typically, if you have a graph and you say vertex labels goes to name, you will have the name that you have given in the first argument.
There's a different point. There's a much simpler point. The subtree needs to say where it's going to, or it doesn't. No, wait a minute. No, does it or doesn't it? No, this is a tree. So the subtree is just a list. Is that correct?
Yes, you can give a list or an association. Yes.
But the association will then implicitly fill in names for those. Oh, it fills in the names for the edges, right?
Right.
When you have an association, indeed, yeah.
Yeah, okay. Okay, so the comment I was going to make about the name isn't, in fact, the name is purely a display feature. The name is not of semantic relevance, except insofar as you're trying to address pieces of the tree. Let's keep going. Go ahead. Go ahead.
No, I was just saying it depends. I think it has the same value as a naming graph, I would say. The naming tree that we are using. So when you do a vertex list of the graph, you get the name you get the vertices, but you get the name. So this is the same here.
Can vertex data contain keys that affect the display? Vertex weight and edge weight as options. I would think yes for those. I can imagine all kinds of computations with trees that are affected by those.
Yes.
This is a mess. No, that's certainly the wrong way around. Surely it will be property 1 arrow inherited.
But you need also to give a value to. I see. No, okay. Yes, I see.
That would mean inherit it from up above in the tree.
Yeah, I see.
Bequeath. That's for genealogical trees or what?
Oh no. So the idea is just the opposite. Actually, you want the parent to pass all its property or some of its properties to the children. So here
I understand. It's right. It's the word in English to bequeath stuff to one's descendants, so to speak.
Oh, I see.
Yeah. It's like when you die, you bequeath your estate.
Well, Ada Lovelace had a good quote that she wanted to bequeath to the generations the calculus of the nervous system. Anyway, irrelevant. Okay, onward.
Right. So so you're trying to say something where automatically this property or whatever is inherited by all the children.
Yes.
I don't.
That is a truly bizarre place to put it, in my opinion. Go ahead, Ita, your comment.
Yeah. So, well, yeah. My first comment is inherited is, is a value, right? So it's property goes to inherited, and that means look up above in whatever structure for the value. Don't think we really have
No, we don't have a force-fed inheritance.
Right. Either we have things which automatically inherit, like styles, or we have things where you need to specify them at each level. So.
Okay. So this is an interesting idea, though. Force inheritance. How on earth do we think about that? Anybody got an idea here? Is Roger here? Johnson?
Yeah, I'm here. So you want to all the way down forcing inheritance?
Yeah, that's a good question. How far does it go? Does that property exist for every tree element, every subtree, or does it only exist for one generation, so to speak?
I see, yes. We will need maybe to specify the number of generation. Yeah, sorry.
Xavier, have you thought about sort of a case where you want, do you have if we could think of a case of where it provides something of, that we think that, yes, I understand.
Yeah, personally, I'm more likely to believe it. I think both of these are kind of weird. Okay, I think that more plausible would be an operator that basically takes a tree and executes, bequeaths, whatever the noun for.
That's what I think too. Because then we can think of all these tree traversals as ways of propagation, and that would seem incredibly natural to me. They can be bottom up, it can be top down, it can be, several other,
Right. So it's basically seeding the tree. It's with the traversal.
And that's what I would expect to do for many of the processing things, is to do that propagation according to, and I think having rich forms of propagation will be, not like our evaluation propagation, which is very special.
So what you're saying is one thing is essentially a scan through the tree of applying some function f, okay?
Yeah.
Another one is an infection through the tree of taking a property that was somewhere in the tree and spreading that property to other parts of the tree.
Yeah, I mean, typically such a you might have some state as you iterate along, but you might go from the top, accumulate more and more as you go down. Or accumulate as you go up.
These are both interesting things. I think they are not for version 1, both the inherited and the force, and the down inheritance, the inheritance from above and inheritance to below, which is what these things are effectively.
I mean, it might be. I just wish we could have a case where it sort of becomes obvious that it's.
Well, let's keep going. Let's look through this. Okay, so rules tree. Okay. Use vertex names.
Yes, so this was to show the alternative way of constructing tree. And this rules tree parsed to a tree element. If you take the input form, you will have a tree element expression.
This thing here.
Yes.
Why is rules tree blue? That's a bad sign. Oh, it seemed to work. Okay. Okay. It's not terrible. So the none are the leaves. The none for the subtrees are the leaves, right?
Yes, that's correct. Yes, when you have a none, yes, there is no children.
Because we wanted to have a case with an empty list, which is different.
That is correct. That it's an intermediate node with no children, as opposed to a leaf node.
Exactly, because we want to be able to replicate our expression structure completely.
Right. Okay, so this one here has an explicit tree element. One of the destinations for A is an explicit tree element. Great.
Yes. Yeah.
How to deal with rule tree options.
Yeah, so here the initial idea was to have the same option as graph, and they will apply to all.
I would think so. If you want something more precise, then then write code that makes the explicit tree element structure.
Yes. Yes.
Okay. Okay. I think I should open all these subtrees. I should know this one. Okay. There's an expression tree. Fine.
Yes. So it takes an expression and constructs a tree element object from that. So we have a few. We can give 3 arguments. The second argument is a structure. So what will be the form and the shape of the tree element output? And the third argument is the level to which we go down.
So what does that second argument mean again?
The second argument is a structure. So by default, we have some other example, yes, below, structures of rules. So here the node, the elided node are lists, and you can have the structure head, you can have the structure sub-expression.
Right.
And the same thing for association and the other structure. And here, those are custom rules. One can alternatively give custom rules. So instead of the string, you will explicitly give a rule that takes elements and transform them to a tree element expression.
So any given element, all elements have to match that pattern. I don't understand.
So the basic question is, what do we consider the triggering of a new subtree? It could be an HTML head, or it could be an entity head, but we don't want to convert into trees.
No, I know, but what's the left-hand side, that XYZ? Where did that come from? Is expa something that has XYZs in it, or what?
So this comes from expa. Expa as
that particular expa didn't have lists in it, did it?
Yes, it's above.
I see that. I see. Okay, fine. Okay. So do you have an example for an XML tree or something?
I think it should be below. Yes.
Okay. By the way, I mean, at the beginning of this meeting, we discussed, this restructuring, but I think we kind of settled this, didn't we, last time? And we went through this at great length. So I don't really think we should yeah. Okay. Let's keep going here. Okay, so this is associations which label the edges. What is this?
So here, this is a way to reconstruct with a custom rule the structure.
Okay, text structure. Okay.
So this is an example of another type of data, and we have built-in rules for it. So one is the head structure, the text element head, and the other one is the text element expression. And we are using tooltip to represent each node.
Well, so wait a minute. So this particular thing, that structure, what is that structure? That structure is a bunch of text elements, right?
Yes, in this case, indeed, yes.
But this is rather unbeautiful. I mean, we should have some way of formatting these that's nicer than this particular thing.
Okay.
But I understand. So this is using text elements.
Yeah, so each time we show that we have 2 versions. We have one version which takes the head, and the other one which takes the whole expression in the node, in the parent node. So we have this for text element, for session, and so on.
Okay, so the way to think about this is the second thing says what to put in each node.
Yes. So for the text element sub-expression, if you have the tooltip, if you hover over one, yes, so we will have the whole sub-expression each time.
I see. Okay. All right, let's look at XML here.
So this is a very, yes, this was a basic example because we have the issue of exactly what you say. So what do we want to represent? And here we can end up with very large. So this is a short, very simple example, but already we can end up with very large.
Well, and the fact that we show nothing on its face is kind of bad.
Yes.
So what would be the natural thing to show in an XML structure like this? By the way, how do we get a tree that is differently arranged? That is, its root is at like the top left, and the tree extends to the right, and so on.
This I will have to add it here with a layout, an option layout, perhaps.
Well, but how does that? I mean, don't we have that already in tree plot and things like this?
Yes, I think it's the option graph layout that is used for that.
Okay, but wait a minute. I thought we actually had a second argument, somewhat unfortunately, to things like tree plot that dealt with things like that. Is that not correct? Does somebody know that?
Yes, in tree plot there is a second argument where you can say, left, right position. So it's the fourth one.
Okay. So we need a thing like that here, don't we? We need maybe we need to have an option name, tree orientation or something.
In graph, you also have orientation. More is tree option.
What is it called?
Orientation.
That's just an option called orientation?
No, it's a string on that graph layout. I think is what Xavier was referring to.
I think you need something simpler here. I mean, I think maybe instead of getting entangled in graph layout, which is way more general, that it's, let's call it tree layout or something like that. Or
tree layout or tree orientation. Oh, yeah, okay, tree layout is probably the right thing. Just like we have graph layout, let's have a tree layout, and the tree layout has some string names and so on that correspond. I mean, tree layout, there's, alternatively, it's really where is the tree root?
Yeah. I think, the graph layout that we have in graph, it's become, it needs to, it's too complicated,
But there's a difference between the layout and the orientation, right?
Yes.
So
yes, that's true.
Well, we could put the orientation information, because the problem is, I don't think the orientation is unambiguous, because I think it depends on, for example, I could imagine top left corner, I could imagine the middle of the left.
But then I think that the kind of things that you described there are sort of, kind of unique to trees.
Definitely, yes.
Right.
So having a tree layout option as opposed to falling to the general graph layout does seem highly sensible, because most of these are totally irrelevant to tree layout.
Right. And really, when we come back to graph, I want to partition this to more user-friendly, kinds of things. It's very general right now, but it's sort of challenging to use.
Right, but here, for example, layered left, layered top, those are things that
but arguably, so when you say tree layout goes to left, that's not per se correct, right? It's the orientation of the layout. So you first need to specify the layout and then the orientation. So the orientation is associated to a layout.
I know. So I'm. This is an elided name. Let's say left rooted. Or top rooted.
But which layout are we using? A layered layout, a balloon layout? Because trees have several layouts. I mean, we kind of use the default one because we are used to it.
What are the other ones?
So there is the balloon layout, which is kind of
what layout?
Balloon.
Balloon.
Yeah.
The heck is that? You mean from the center?
Exactly. Yeah. So kind of a.
Yeah, but it has a, it's useful. It has some other kinds of useful.
Well, Xavier, have you looked at any of these things with things like a balloon layout?
No, we look into it.
Well, let's look, for example, at this. We could take your XML or something. Well, no, we got that one. Okay. What happened there? That, by the way, was bad. And we do need to change the default size of the tree to be something reasonable, right? Based on the number of nodes or some other heuristic.
Yeah.
Am I making sense?
Mm-hmm.
And we agree, and we're doing that for graphs as well, right?
Yes.
I think that the balloon will not, for this case, it's verbally, textually oriented. Balloon would make no sense whatsoever. Do you see what I'm saying? I mean,
one advantage of balloon is when the graph get bigger and you have less label.
That's true. You know, it shows structure very well, but this one you kind of want to read, you know, so reading around a circle is not so good.
Okay, so in this case, how do I get the can I use a graph layout option here?
No.
Is the final thing a graph? Is this thing a graph?
It is, yes.
Okay, so how would I do the layout? I would say graph on this again. Graph layout is whatever.
Graph layout goes to, and yeah.
Okay, this autocomplete is totally broken, as we discovered in a previous meeting.
Mm-hmm.
Balloon, is that what it should be called?
I think it has a secondary, you know. Charles, what is the full name?
Balloon embedding.
Nope. Well, something went wrong there, so we have to investigate that. Okay.
The input is not a graph.
What's that?
I think the input is not a graph.
The input is a tree element, yes.
Okay. Well, so how do we get that? How would we turn that into a graph?
This should be
tree graph.
Tree graph, exactly, yes.
Although note that, you know, you're almost surely going to be losing some structure there.
Yeah.
But then specify that balloon thing. You can see it. Comma.
Yeah. Come on. Oh, I see what I have to do.
Yeah, this
Hit
is
down
tree
here.
element, which is companion actually, yeah.
Okay, there we go. Cool. I mean, useless in this case, but a cool, yeah, I mean, definitely useful. So we want a tree layout, which will be an option to all of these various tree functions, which will determine what the graph embedding should be.
And you, Xavier, you can select and pick among them, right? So we curate a good set of such from what we already have. And
right. I mean, so we want layered top, layered, probably we want layered bottom, which you probably should also have for graphs, Charles. Things that grow from the bottom, right?
These are packing. These are packings.
Those are orientation for embedding. So if we do layered embedding, top, bottom, so essentially the layer embedding will have 4 options, 4 different ones.
This is incomprehensible, guys, in case you didn't notice that.
I told you it's challenging, you know. It needs to be.
Yeah, okay. Your word is challenging. Mine is incomprehensible. Are there examples that make it clear?
Yeah, but they're not sort of clear enough. Okay, I think that it needs to be separated a little bit. You know. But it requires real. It's not just that. It needs some additional. It's not super quick thing to do.
Okay, fine. But at least Xavier can get
Xavier can get what he needs for sure.
Okay. And maybe working with Charles to pick out the ones that are relevant.
Right.
Okay. How to typeset composed heads.
Yes, sorry. So the with is actually a hack. It should not work. So the idea is that the first one you have F as a head and A at the leaf. And in the second one, you can see that F of A is not actually typed as a tree itself. So the question was, do we want that? So here, this is a hack with a with and something. But the question is, do we want to typeset a tree element into a tree element node. So we will have to specify probably a level for if we have deeply nested node within node and so on. We will have to specify a level to stop typesetting at some point. But do we want it at all, or
for what? Sorry, what are we saying? Do we want this weird thing?
Yes, well, yeah, indeed, this is very weird here, but we have actually something. This is not weird for graph. I'm going to send you.
So I think there are two separate things here. One is whether we allow a tree to be the content of a node, and then the other thing is how do we typeset that?
Yeah.
So for the first one, I think we should allow it.
Now, look, if you explicitly put a tree as the content of a node, then the node is going to expand, it's going to puff out to, I mean, you could put a whole giant graph as an element of a node, and then you would want to draw the graph here, and that's fine. Now, the question is this graphically the best thing to do? And that's not so clear.
Yeah, treeform is not able to do this either. Treeform of f of a of b.
No, this shouldn't be the default. Right, but okay, yeah, I see. Look, the problem is that graphically this is bad. Right, but that's a question of how we choose to render the nodes, not the question of whether we should have a node within a node.
Mm-hmm. Right.
I think it's okay to have a node within a node, but not with these giant yellow wings on it.
Yes. So here this is very bad. So this is something we have started discussing with Chris, and I will discuss it again with him.
Okay. What name for the structure where heads are represented as nodes?
Yeah. So usually this is done as an option, for instance, with level. But here this is a third expression tree evaluation. This can only apply when we are looking at the sub-expression structure. So the main idea is only that you take the head of the sub-expression and you put it as a node, as a child. So this is very similar to what we have for level. So you have the level of the head and the level of the part of the expression are the same. And we wanted to be able to represent that in the tree structure. But the name seems very bad to sub-expression with head.
Listen, we've got quite a bit of other stuff to go over here that we are not going to finish right now because I've got another meeting coming up. This is going to need at least another hour and a half, 2 hours, I think. Mm-hmm. How much? Let me just see. Tree objects and graphs. What's this about?
So this is to transform a tree into a graph and a graph into a tree.
Right. Okay. Other manipulations, which there are quite a few, right?
Yes. So here tree rules take the rules of a rules tree. Tree insert is to insert a tree, and so on.
Tree rules gives the rules version of a tree, right?
Yes, exactly.
Tree insert puts a subtree at a particular position.
Mm-hmm. Yes.
Specified by positionally or by an association, name sequence. Tree replace. So insert makes this be that position, basically. And what does it do if it's not contiguous?
So here you have an example. Are you saying about the last example, for instance, 3.5?
I don't know. Maybe. I mean, I guess my question is, oh, I see. That's an empty one that was put in there as a placeholder. Is that correct?
Yes.
Well, that's a very ugly way to do it.
You take the position 3. So it's really like insert. So the first one would take the position 3.
Well, what does insert do? Insert just fails, doesn't it? If I say insert into the list ABC an X at position 10, just says it can't do it.
Mm-hmm.
Right? It can do it if you do it to position 4, but I don't think it can do it to position 5.
No, but here the same for tree insert. It will complain.
Well, what's this node thing? Oh, that's okay.
Yes,
Fine.
Yeah.
That puts it in 2B position 3 and 2B position 5.
Well, this is 5 plus 1 because we have inserted 1 earlier. Yes. So this is really like.
How does insert do that?
It's the same.
Yes. Okay. Fine. Yep. Yeah. Okay. It's at old position 5.
Yeah.
Okay. By the way, have you started documenting all of this stuff?
No, not yet.
We should start that.
Okay.
Tree replace. What is this doing? This is replacing an actual node or a subtree. Is that correct?
Yes.
But you know that's going to be messy because these trees, the canonical form of these trees is complicated with all these associations and things, right?
Yes, this is something that we wanted to discuss also. These are for pattern for trees. Yes, at least to avoid evaluation.
What?
So here, if you want to give a tree element, since it's going to in the rule of tree replace, it's going to evaluate. So to do this properly, it might be better to introduce a tree pattern symbol.
Oh gosh! I mean, the alternative would be to clean this up and to make sure that there is that the tree replace knows that these things will have been canonicalized and that it can, for example, treat the associations as orderless, et cetera, et cetera, et cetera.
I see.
That's what I would do. I mean, I think having a whole tree pattern thing right now seems unfortunate.
Mm-hmm.
Okay, tree extract. Right. What is tree path now?
So this is a wrapper to select the path for tree extract. And we can have integers, string, and so on, depending on the query that is performed. And we can have a list of tree paths or just one tree path. So this is typically used to mix part specification and extract specification.
Okay, but okay, so tree pattern is content of the tree. Tree path is position in a tree.
Yes, exactly. Yes.
This may be another horrifying thing. Look, we're going to need quite a few more hours on this. This is, and we should also decide who in this meeting actually needs to be here for what we're doing and what other issues are going to come up, because we have not discussed. I mean, I don't know what's needed for example, XML tree manipulation. Does anybody here have an opinion about that? And are the functions that we're providing here adequate for XML tree manipulation?
We have looked at this XPath language, which is very close to XML.
Yeah.
And we have imitated some of the ideas. In particular, being able to go up and down in positions and query in the process.
Yes, I understand, but that's often from a given place in a tree. I mean, that's in a procedural way of dealing with a tree. You're sitting at a particular node and then you're doing things. But I guess if we have a node specification, then how do you apply a function at a particular node in the tree?
On the vertex data?
What?
You mean on the vertex data or on the whole tree element expression?
On the tree.
On
so
the
in other
tree,
words,
okay, so
I want to apply a function at a particular position in a tree. And for example, I might want to look above me to find out, you get what I'm saying?
Mm-hmm. Yeah. We don't yet have a tree map or tree apply, right, Xavier?
No, we don't. No.
Right, but but Stephen is really asking for like a tree locate, right? Like notebook locate. You find this element and then go up a level, which is different from map or apply.
Yeah, that's possibly true. Well, but I would also be happy to have something where I can apply at this point in the tree, right? But be able to address in doing what I'm doing, make a replacement, whatever else I'm doing to that subtree. But in doing that, look up above me to, to see what context I need to use and so on. Am I making sense?
Sorry, but here you can't have a reference to an element. You always deal with the whole tree, right? You cannot have a reference to an element and query the parent, can you?
Well, yes, you can, because you can have every tree element has an address. So if you say, apply this function at this tree element position, right?
Yeah.
Or alternatively, you could be mapping all the way through the tree. You could say, go to visit every node of the tree in a depth first traversal of the tree, and at every element, look above at its, grandparents and so on, if it has them.
Yeah. We can extract all the uncles and etc. of a given node, but currently we cannot map a function on them.
Right, I understand. So we're going to need that. We're going to need some kind of tree. What is this? It's a. What will be the analogous function in an expression?
Map at.
Map at. Yeah, map at. This is some kind of tree map at. But possibly, tree map is a more important thing, because that's the thing where you scan a whole XML expression or something, looking for all occurrences of this, given that it's in a context of that, and so on.
Maybe there is a cool tree fold.
Yeah, maybe there is. What would that mean? I've heard of tree foldy type things. So let's just think about that. So that means you are, because a tree fold will unroll itself and then re-roll as it goes down. So in other words, given a particular path through the tree fold is the thing that has accumulated itself going down that path.
Right. And what we could do, is to say, how do you flow through it? How do you traverse it? And it might be a very cool functional way to package those, actually. Because you have a state, right? Like in fold. And then you have the things that are coming in from the tree, depending on which path you're taking.
Exactly. But then it rolls and unrolls, right? Because as depending on the path. Right. So that's a. I had a parameterization. I hate to always say this kind of thing, but I had a parameterization of this type of thing for evaluation in SMP. I had two parameters that represented this, which were just utterly incomprehensible.
Yeah, it's not necessarily super easy, but I think having concrete cases to work with there is going to be super.
Yeah. But no, I really like the idea of a tree fold. I think that's very interesting. And I think that, tree fold, look, it's clear there's depth first, breadth first. Those are two, ordering criteria. And in general, the ordering is, in general, what you would do to define an ordering is you would say it is something, it is lexicographic on the parts, on the part numbers, for instance, or whatever it is, right? Our map, map also has never defined a traversal order, right? Map is essentially depth first on the part numbers.
Right.
Now, clearly, when you have something where the tree branches are labeled by keys in an association, things get a little bit more elaborate because you don't just have a numerical sequence to deal with. You might have some more complicated ordering criterion, which might get even more messy. But even if you just take the numerical ones, depth first corresponds to one particular, in other words, if you say, where did you visit, right? Depth first, you can just put down all of the locations where you visited, and depth first corresponds to some kind of lexicographic sorting, breadth first to another kind of sorting, and so on, right? And so I think it's defined by that sorting, by that ordering criterion on the locations. And I don't know whether that's, but yeah, my guess is that those two get you a large, I mean, look, the other one is negative levels for map, where you're coming up from the leaves of the tree. Right? That's the other one that we've had for a long time.
But this is an operation we don't have in the expression world. So perhaps this is more like a traverse, like a tree traverse.
Yes.
And it could exist with expressions also called traverse.
Right, which is a way of visiting expressions in some random order.
Right.
Right. It could also be a traversal order option to map. Because I think it's fairly obscure. I mean, in 30 years, we haven't really had a particular need for it, to be fair. Mm-hmm. And when I put something like that into SMP, it was one of the absolutely incomprehensible features.
We build it sometimes in C code when we need it.
Mm-hmm.
Fair enough. But I think a traversal order option to map would be highly interesting. And I think treefold is highly interesting, and we need to wrap this meeting. So, to be continued, presumably, hopefully early next week. Looks very nice. So this code, is it going into the head branch or the Xkernel? Where is this code, Xavier?
So we will put this in Xkernel, yes.
Okay. Go ahead.
This is basically a prototype. So we should have something better, faster than this.
Okay. I mean, how close is this to being usable?
This is usable with small cases.
That's good enough to start.
Mm-hmm, mm-hmm, yeah.
Because I think this is going to require some design shakedown still. I think getting this in as experimental, even if it only handles comparatively small cases, is highly worthwhile. Because I predict there are going to be some things that aren't fantastic in the. I think you should start documentation on this stuff. I mean, this is, I have to say, this whole subsystem has turned out to be unbelievably much hairier than I expected. I have to say. I mean, in a sense, this is almost as complicated as the graph subsystem in many ways, which is surprising to me. But anyway, so it goes. I mean, by the way, of course, the analog of traversal for a graph we don't really have, do we? Or do we?
We do. We have breadth first scan and depth first scan.
Oh yeah, right. Which we, by the way, could use those exact same functions for trees.
Yes.
And we should.
But they're complicated, Stephen. They're very general, but they're complicated. So I would encourage us to try to find, easier use cases.
Yes, I understand.
Might not cover everything, but yeah.
Right, which might not work for trees, for graphs.
Right.
But we probably should have the things that work on graphs also work on trees, where the trees are treated as if graphs, so to speak.
Right.
Meanwhile, I mean, graph replacement is something I really would love to see us do, but that's a different conversation. But we can, tree replacement is a lot easier. All right. Okay. All right. Talk to you all soon then.
Okay.
Bye.
Bye.
Bye.